Good morning. So, in the last video, we have seen the classification of turbines, right? Now, next we are going to see the efficiencies of the turbines. So, basically, when you talk about efficiency, what do you mean by efficiency? Output by input, generally, you call it as efficiency. Now, here, when you talk about turbines, you have got four different types of efficiencies. The first is hydraulic efficiency, which can be defined as the ratio of the power delivered to the runner divided by power supplied at the inlet. Mechanical efficiency, we have power at the shaft of the turbine divided by power delivered by the water to the runner. Generally, you call it as SP by RP. Volumetric efficiency, which can be defined as volume of water actually striking the runner divided by volume of water actually supplied to the turbine. And overall efficiency, we can define it as volume available at shaft of the turbine to the power supplied at the inlet of the turbine. That is shaft power divided by water power. So here we are going to rearrange it as shaft divided by water power. We can also rewrite it as SP by WP into RP by RP. There is no harm. You're just doing a little bit of jugglery. Then which you're going to again rewrite it as SP by RP into RP by WP. You know that SP by RP is nothing but mechanical efficiency eta m, and RP by WP is nothing but eta h, which is the hydraulic efficiency. Or we can say that the overall efficiency will be equal to mechanical efficiency into hydraulic efficiency. So these are the basic efficiencies of the turbine. Probably you may be a bit confused, but as you do a problem, it will be clear, right? Now, let us go to the first type of turbine. First turbine, what you're going to learn is Pelton wheel turbine. Probably you might have done the experiment in the lab with Pelton wheel. So this is the image of a Pelton wheel in the laboratory setup. And the parts of the Pelton wheel, we'll see in detail, right? So what type of a turbine is Pelton wheel? Pelton wheel turbine is a tangential flow impulse turbine. Now let me try to recollect it. What is the difference between an impulse turbine and a reaction turbine? In an impulse turbine, at the inlet of the turbine, the energy available is only kinetic energy. It will not have potential energy with it. Please again, once more, recollecting it, impulse turbine, the inlet of the turbine, the energy available is only kinetic energy. Then you call it as impulse turbine. And you know tangential flow turbine. What do you mean by tangential flow? That according to the direction of flow of water in the turbine, you classify it as tangential, radial, axial, mixed flow, right? So tangential flow turbine, you know the water is flowing tangentially along the runner. You call it as tangential flow turbine. So Pelton wheel is an example of tangential flow impulse turbine, and also it is a high head turbine, which means the head of the turbine will be around 250 meter to 1770 meter. Now see, look clearly at the image of the turbine. What are the parts do you see? This is the runner of the turbine, right? And here you have the buckets. These are called as the buckets of the runner. You have a penstock, spear. Spear is nothing but a kind of handle. You have a nozzle here. The water will be coming and impinging, directly impacting on the runner. This is the overall casing, and you have a brake nozzle. So these are all the parts of the Pelton wheel. This is a very important question. Explain the parts of the Pelton wheel, right, with the function of each part. Now let us go to the function of each one. First one is casing. You see, this is also another photograph. So see, you know what is a casing. Casing, see anything, casing means it protects, right? So casing is provided to avoid accidents and also splashing of water. Basically, this casing do not have any hydraulic function and it is made of cast iron. What is it? It is made of cast iron and it minimizes the wind losses. So the first part in Pelton wheel is the casing, right? Second one is what you call as penstock. See, again I'll show you the picture of penstock. This is the penstock. A penstock is nothing but it is a gate or an intake structure that basically controls the water flow. So it is being controlled by a hand wheel and that is what you call as spear. See, you can see here this spear. This spear will be controlling along with the penstock will be controlling the entry of water into the turbine. You have a nozzle of a Pelton wheel. See, you can find this. This is a stationary nozzle. This nozzle is a circular guide mechanism which guides the water to flow at the desired direction. See, if this, see here again, you can see this. This nozzle is something which is directing the water towards the buckets. If this nozzle had not been there, the water would not have gone and directly impacted the bucket. Okay. So that is nozzle. The next is spearhead nozzle. Again explained that a conical or spear needle operates inside the nozzle in axial direction. It is basically done to regulate the flow of water through the nozzle, right? Runner. See, this is the runner. This is the runner. Again, you can see this is the runner. So what do you find in runner? Runner consists of a circulating disc fixed with a horizontal shaft. And on the periphery of the runner, there you can see buckets. See, this is the runner. You can see buckets which are uniformly spaced or equidistantly spaced. Next is bucket. A bucket is nothing but a hemispherical cup or bowl with a divider in the middle. This divider is known as a splitter. It splits the water jet into two equal parts and the surface of the bucket is made very smooth. Then you have a shaft. It is horizontal and connected normally to the runner, which produce mechanical energy when jet of water impact on runner. So you know what's a shaft, right? Then you have a braking jet. See, again I'll go back to the image. This is the braking jet or the brake nozzle. It acts as a brake for reducing the speed of the runner. To bring the runner to rest in short time, a small nozzle is provided in such a way that it will direct the jet of water on the back of buckets, right? Now see, what is the working principle of a Pelton wheel? So the basic principle behind the working or functioning of Pelton wheel is impulse momentum. Principle of impulse momentum. So how does it work? The high-speed water jets emerging from the nozzle strike the buckets at splitters placed at the middle of the bucket. There, the jets are divided into two equal streams. Now see, again I'll tell you with the help of diagram. So see, this water, it is coming and it is striking this bucket. Actually, this is a hemispherical bucket. Now here, if you see the bucket, the shape of the bucket, you'll find that there will be a splitter. I'll show you the image. There will be a splitter. So what happens is, because of the splitter, the water gets split into two equal streams. See, for example, I can show you. This is the splitter. Do you find this? So this is the bucket and this is the splitter. So this splitter divides the water into two equal streams. These stream flow along the inner curve of the bucket and leave it in the direction opposite of the incoming jet. See, obviously, when the water is striking here, this will go through this and this will go through this, right? So it will be coming out in the opposite direction. So these streams, what will happen, that will rotate the runner. Due to this, shaft also rotates and that will produce electricity. The high-speed water jets running the Pelton wheel turbine are obtained by expanding the high-pressure water through nozzles. The high-pressure water can be obtained from any water body situated at some height. That is, normally you use a dam, right? It can be used application. It could be used to measure the speed of the fluid, and also obviously this is used for power generation. So this is the working principle of a Pelton wheel, right? Hope I'm